Welcome to our lesson on the solar system. Today we're going to focus on the planets, and then we'll take a look specifically at Earth and its seasons. Let's dive right into it. I'd like you to memorize the order of the planets coming from the sun all the way out to the far reaches of our solar system. It's called a solar system because solar means sun. So we have one star in our entire solar system. The closest planet is Mercury, then we have Venus, then here's us, third rock from the sun. Then we have another one, Mars, which you've heard lots about, I'm sure. These inner planets are all quite similar, and they're all very, very close together. In fact, this picture here at the top is a little bit deceiving. This one down below gives you a better idea of how close they are actually to each other. So the Earth sitting here is third rock from the sun, and Mars is just a little bit farther out. But then it's actually quite a huge distance until you get to Jupiter. This number 5 right here, the unit is astronomical units. And if you look down below, you can see that an astronomical unit is the distance between the sun and the Earth. It's about 150 million kilometers. So all of these distances here are based on how much farther away something is than the Earth. So about 5 or 6 times farther from the sun than the Earth is from the sun. So it's five and a bit astronomical units. You can get more data off the chart on the next page. Saturn as well, almost 10 times the distance of Earth. Uranus, about 18 times, 19 times. And then Neptune, about 30 times. And you can see Pluto doesn't even factor in on this map. When you look up here, you can see that the inner planets are much, much, much smaller. And in fact, they are made of rock and other sorts of elements. Whereas these huge big giants, these giant 4 on the outside here, they're called gas giants. They're actually mostly made of gas. They do have other things underneath the surface, but we're still guessing about what's there, and mostly they're just made of huge big gas balls. So you get an asteroid belt in between, and you can see that in this picture here. You can see there's the asteroid belt. This is just random rocks left over from whenever the solar system was created, all these random rocks that are here, and they are in between Mars and Jupiter. And there's lots of theories on why they're there and the fact that they might be disappearing. Maybe we make collisions with them and that's why we see craters, and maybe every now and then they get knocked out and they head towards us and they might form meteors and things like that. But lots of theories about that, still waiting to be proven conclusively. So we go back up here then. The sun, Mercury, Venus, Earth, Mars, then the asteroid belt, and then the gas giants, Jupiter, Saturn, Uranus, Neptune. And then way far, far out, doesn't even make this little chart here, is Pluto and a whole bunch of other dwarf planets. Pluto, we actually just had a probe go past Pluto and make some really beautiful pictures. So be sure to check out that video on our online classroom about Pluto. Beyond Pluto is something called the Oort cloud. It's another whole section, looks similar to the asteroid belt, except these are giant chunks of rock and ice. And this is the source of all of our comets. Eventually, a comet will get knocked out of this Oort cloud, and it'll start hurtling towards the sun, and it goes past us along the way, and we get to see it in the night sky. It doesn't actually interact with Earth. They're actually quite far away from Earth, but they do leave behind rock and dust that we'll talk about in another lesson as they head back around the sun, and then they escape. So please memorize the order from the sun all the way out, and you have to include the asteroid belt, 4 inner planets, asteroid belt, 4 outer planets, Pluto, and then the Oort cloud. That is a test question. One of the easy ways to memorize the planets in order is to use something called a mnemonic device. It's just a way to memorize something. So you take the first letter, M-V-E-M, and you make a sentence out of it. M-V-E-M, my very excellent mother. Then you have your asteroid belt, and then just served us Nutella, J-S-U-N. You can make up whatever you like. Some people like to use these to help them to remember. All right, let's move on. Now, beyond this asteroid belt, when we get far enough out, we actually believe that the sun is now so far away from any water that there's something called a snow line. So the asteroid belt is the snow line where the sun cannot heat up the water that far away from itself, so all the water beyond it is frozen. Any water closest to the sun that's just floating around in space would actually, they believe, be in a gaseous phase, so it'd be water vapor closer. Although the average distance between the sun and the Earth is about 150 million kilometers, The actual pathway or orbit of the Earth around the sun is not a perfect circle. It's actually more like a little bit of a squish circle, kind of like a bit of an oval, ever so slightly. And so because of that, at some times in our journey around, we are at perihelion, which means we are closer to the sun. Helios is the word for sun. So perihelion is nearer to the sun, and aphelion is when we are the farthest away that we'll be. Although you would think, hey, if we're closer, maybe we must be hotter, and if we're farther away, maybe that's when we are colder. That's actually not what explains our seasons. We'll go through seasons shortly. This is just, I'm sure it does make a slight difference, but this is the range that the Earth lives within. It's about 5 million kilometer difference between the closest and the farthest away. And we have to be within this range in order to sustain life on Earth. As far as we know, we are the only planet that's able to sustain life in our solar system. And we believe it's because of our relationship to the sun and exactly how much sunlight hits us, how much radiation hits us. It has to do with the composition of our atmosphere and so on that protects us from the sun's harmful rays and allows us to bounce off a lot of the bad radiation, bounces right off of our what's called a magnetosphere, which is basically the Earth is a huge big giant magnet. And so bad particles from the sun that otherwise would consume us bounce right off. That's pretty amazing. All right? So perihelion, aphelion, make sure you know these terms. Close, far away. So let's take a look now, and we'll actually compare the 4 rocky planets, and then we'll take a look at the 4 other ones. Now, notice this one, obviously we're not dealing with distance between them, but we are dealing with size. You can see that the Earth is almost the same size as Venus. Venus is ever so slightly smaller, but you can see it's quite large compared to both Mars and Mercury. And if you take a look at this chart here, it gives you a little bit more information. So the Earth is at 1 because the distance is considered 1 AU from the sun. And you can see Mercury is less than half the distance, Venus is about a third of the distance, and then Mars is 1.5 times that distance. And you can see the differences in their sizes as well, and in their masses. Notice that it says Earth mass because everything's compared to Earth for this. So if Earth weighs 1, then you can see Mercury and Mars both weigh about 10% the mass of Earth, whereas Venus is about 80% the mass of Earth. Notice as well, though, there's a massive difference in their surface temperature. Mercury closest to the sun has 180 degrees Celsius. Now that can range because it depends whether you're talking about the part of Mercury that's facing the sun or the night side of Mercury that's away from the sun. And then you have Earth. Our average temperature is about 17. Some people say 15 degrees Celsius around the Earth. This is what allows us to sustain life. So when some places are at minus 40, other places are at plus 40 or plus 35, and that allows us to, on average, be about 17 degrees Celsius. Okay? And notice Mars, being quite far away, is negative 60 most of the time. So it'd be very, very chilly to be on Mars. Notice, though, Venus, which is right smack in the middle of Mercury and Earth, is actually extremely hot on its surface. And that's because Venus actually has an atmosphere. We'll talk about that in a second. Another bit of information I'd like you to notice. So Earth, 1 day, 24 hours, right? Well, notice that 1 day on Mercury is 60 days. So it takes about 2 months for Mercury to have its one single day. And that's because it's rotating so slowly. Then you also get Mars is about the same length of time, just a tiny bit longer than 24 hours. And then look at Venus, 240 days. That's 2/3 of a year for us, about 8 months worth of time for them to have 1 day on Venus. That's a very, very, very slow rotation. And if you take a look at the revolution and you compare this, now these are compared to years, but if you say 365 times 0.2, then you'll see that Venus actually has its day, its slow rotation spin is actually longer than its year, because 0.6 of 365 is less than 240. So Venus is the only planet that's got a day that's longer than its year. Tuck that piece of information away because that is worth a test question. All right, let's look at some more details for each of the individual planets. So here we've got Mercury. Mercury is the planet closest to the sun. Surface is similar to that of the moon because it has no atmosphere. That means that when little pieces of space rock smash into it, they can form craters. However, even though there are scars on there and we see impact craters and things like that, they keep getting filled in because they have a lot of lava flows going through all those cracks and kind of filling up the gaps and renewing the surface every single time. So it's basically like they've got massive volcanoes that are constantly pouring rock out and then renewing the surface. So a lot of its surface is actually smooth, even though it does get struck by a lot of rocks in space. Okay? And again, we can go from 400 degrees in the sun to negative 180 degrees on the dark side, which would be the side that is turned away from the sun. Venus, again, very similar to Earth. It got about the same diameter, only slightly smaller. It's got about the same mass. It's got about the same type of gravity because of its size. But it's actually very much so unlike Earth. It is so hot down there because of something called the greenhouse effect, which is a topic that you'll cover in more detail when we talk about climate change in grade 10. This greenhouse effect is caused by a very, very thick atmosphere, so that when heat comes in from the sun and it goes through its clouds and it goes down and hits the surface, it can't escape again, so that it just constantly stays hot. So about 450 degrees Celsius, hot enough to melt the metal lead, which is crazy. It also has an extremely high atmospheric pressure, so it's super hot. You'll be squished by the air, and in addition to that, it rains sulfuric acid. It'll burn right through metal. Now, in 1982, Russia landed a probe on Venus. It's only lasted for less than an hour, 57 minutes, because of the crazy temperature, the crazy pressure, and the sulfuric acid rain just ate right through the little probe, and it stopped sending pictures back to us. And then in 91, we had a spacecraft called Magellan that flew past, and it was mapping Venus using radar to try and figure out what the surface would kind of look like. And then in 2006, we saw another one. And so we're continuing to try to understand what the surface looks like. We're trying to understand what the atmosphere is like. But we've pretty much given up the idea of moving to Venus, even though it is one of our closest neighbors, because when you actually look at Mars, Mars is a much more suitable planet for habitation, to actually put a human colony on it. And that's why all the emphasis has been on Mars. Let's take a look real quick at the Russia probe that landed, and I'm going to quickly show you what that looked like on the surface of Venus.
While named after the goddess of love and beauty, the second planet from the sun, Venus is anything but. Some refer to Venus as Earth's sister planet. It has a similar size, mass, composition, and even proximity to the sun. But because of its dense atmosphere and incredible atmospheric pressure, Venus has become the hottest planet in our solar system. In today's video, we're going to take a look at what the few missions which survived the trip to the surface actually found. While NASA was putting all of their efforts into landing a man on the moon in the 1960s, the Soviet Union was equally busy with other space-based projects. The Venera program was a 23-year-long mission lasting from 1961 to 1984 and would see humanity breach the atmosphere of another world for the very first time. The early Venera launches were met with complete failure. In 1961, the Soviets launched Venera 1 and 2. They were flyby probes designed to fly past Venus without entering orbit, to return information and images. However, the instruments on the probes failed after leaving Earth. It is thought that Venera 1 remains in heliocentric orbit to this day. Venera 3 was the first minor success of the program. The atmospheric entry probe became the first man-made object to touch the surface of another planet. This, however, was a crash landing. The data probes broke when Venera 3 passed into the Venusian atmosphere, and so no data was achieved. Things improved rapidly from this point, with missions beginning to survive atmospheric entry with their probes intact. Plenty of information about the planet's atmospheric composition and topology were gathered, but it wasn't until 1976 that we began to receive images from the Venera missions. These early images from the surface painted the picture of a rocky world choked by its carbon dioxide-rich atmosphere, an arid and lifeless environment. None of these probes lasted a particularly long time. The incredibly harsh conditions on Venus broke the equipment of the probes incredibly quickly, with the longest ground mission lasting only 2 hours. Russia still has plans for future forays into the Venusian landscape, with Venera D currently planned to launch in 2026 or 2031. It is said to include a highly capable orbiter and a landing array. While the Soviet Union's Venera missions may have been the first to venture into the atmosphere of Venus, NASA has followed up with their own missions. The majority of NASA's missions to Venus have either been simple flybys or brief gravity assists using the planet to get to other locations. In fact, NASA only ever sent the Pioneer Venus multiprobe into the atmosphere of Venus. Part of the Pioneer program, this spacecraft bus was carrying one large probe alongside 3 smaller probes and penetrated the atmosphere in late 1978. If there's one thing we've learned from all of these missions to Venus, it's that the planet no longer harbors any form of life on the surface. The ground is dark and rocky, scorched by the incredible heat and pressures present on the surface. Above, thick layers of clouds swirl in an impenetrable blanket. While the majority of the gas on Venus is carbon dioxide, the clouds are made up of sulfur dioxide and droplets of sulfuric acid. We haven't been able to spend much time on the planet, but the weather on Venus is under almost constant study by telescopes here on Earth. We've learned that the planet's weather is violent and extreme. Unlike Earth, the atmosphere of Venus orbits the planet at rapid speed, with winds frequently reaching up to 186 miles per hour at the cloud tops. This means that the wind of the planet moves at around 60 times the speed of the planet's rotation and are fastest at the poles.
Now let's take a brief look at the 4 outer planets, the ones that are known as the gas giants or the gaseous planets. They are quite a bit farther away from the sun than any of the other ones. Remember that 1 AU is the distance between the Earth and the sun, so Jupiter is 5 times that distance, Saturn's almost 10 times, Uranus 19 times, and Neptune 30 times the distance. That is really, really, really far. And if you were to compare the radius of these guys with the radius of the other guys, you'd see this is ridiculously huge compared to the rocky planets on the inner part of the solar system. You can also see they are much, much colder, and their Earth days, the length of their day would be much shorter than the Earth day, less than half and about 2/3 of an Earth day here. And then here you've got the revolution, so you've got how many years it would take for it to go around the sun. So 12 of our years for Jupiter, 30 for Saturn, 84 for Uranus, and 165 years is how long Neptune's year takes, 165 of our years. So that is an incredibly long time. So Jupiter, we looked at it through telescopes for a very long time, and we actually thought Jupiter was a fancy star. And there was plenty of, before we were looking at it through telescopes, there was plenty of different myths and associated with all of these gas giants because you can see them with the naked eye. It looks like a bright star that moves a little faster than a normal star in the night sky. You can take a look at Jupiter most nights. So read through this information about Jupiter, read through it about Saturn. Saturn's the one with the big, beautiful rings. Uranus is a little bit different. It actually rolls like a ball rather than spinning on an axis that's almost upright. Its axis, you can see, is sideways like this. You can see the way the clouds are actually spinning around in this direction. That's because it lies like this and rolls around the sun like a ball. But go ahead and read through this information for yourself. You're welcome to jump onto YouTube and take a look and see what you can find about these different planets. It's actually really quite interesting how we figured out what we know and how much more we know now than we did when these original different experiments were taking place with the probes that were going past them. We have way better pictures than even this textbook knows about. I'd like to run you through an idea of the scale of our solar system. If you go to our online classroom and you go to the content section, go down to the space unit, you can see that there are going to be some links here down at the bottom for the YouTube. So go ahead and make sure you take a look at these videos here, give you an idea of the scale of the solar system. And there's a little interactive here as well that I'm just going to run through with you. If you want to see even more images, there are some other longer videos here that I highly recommend that you watch. Treat this as homework and make sure that you watch all of these here. You can skip the sun one until we do the sun lesson, but you do want to maybe watch some of the other ones that are all comparisons and the idea of what type of things we actually do see in our solar system. So please go ahead and do that. In the meantime, let's take a look at this animation right here. Okay, so here we can zoom in if we like. There's the size of a basketball, something you're familiar with, hummingbird, chicken egg, square inch. So if you had a ruler and you had that as the width of an inch, that'd be a nice square. Coffee bean, glass marble, sunflower, an ant, duckweed. We're going to go in closer and closer and closer. Grain of sand, human egg, width of a human hair, and so on. This allows you just to keep going and going and going. It even gives you the width of wavelengths of light. Silk. Keep going, keep going, keep going, keep going. A little bacterium, a chromosome inside one of your cells, and so on. And you can keep going in this direction. But we aren't studying this direction. We're here now, we're looking at the size of viruses in comparison. Let's zoom out because we aren't looking at microscopy. We are looking at the astronomy of the universe. So let's just pull right back out. And you can play around with this for yourself and take a look. Okay, so here we are back where we started. It's about 1 meter across. Let's zoom out. Height of a person. Whoa, giant earthworm. They weren't kidding when they say giants. Longer than a human. Let's keep going. Sunflowers, giraffe, and elephant. Interesting that the T-Rex is not that much larger than an elephant today. Lunar module, oak tree. Whoa, that is a big dinosaur. Boeing 747, Statue of Liberty, the Titanic, a football field. This is the International Space Station, so you can see it's about the size of a football field, a little wider and about the same length. The Great Pyramids of Egypt. Keep going and keep going and keep going and keep going and keep going. Now we're starting to get into the size of things that are in our out in our solar system. So we have the size of Halley's Comet. We've got different rocks and whatnot that are floating through. Here's the size of a neutron star. Notice it's actually much smaller than even some of the larger rocks and moons that are flying around the other planets. And so neutron star is actually quite small. Okay, here's some more moons, smaller than the size of the country Rwanda or the state, West Virginia, smaller than the Grand Canyon. Okay, Italy, California, Texas. Here we're getting into, there's Pluto, and then here's a whole bunch of the actual different moons that are around other planets other than Earth. There's our moon, size of our moon. Notice Pluto is smaller than our moon. Okay. Now we get into the size of our planets. Here's the 4 rocky planets. So from the sun, we have Mercury, Venus, Earth, and then Mars. Okay. And then we're starting to get into small stars. Notice that star is smaller than our gas giants. So here we've got Neptune, Uranus, Saturn, and Jupiter. And we can go on and on and on. Now we're starting to get into sizes of different objects that we've seen far, far, far away outside of our solar system. Things like stars or planets that we've seen. Okay? So here we're getting into, there's the size of our sun and so on and so forth. And you can see that there are plenty of stars that are there's our sun there, that are much, much larger than our sun. Aldebaran is a red giant. It's one of the major ones, closest ones that we can see to us. Polaris, which you'll see in another lesson, is actually the North Star. You can keep going and you can keep going. So feel free to come in and play with this and go through it for yourself. I just wanted to give you an idea of the scale, the fact like you can't even begin to see the Earth from here. All right. Here we have the Kuiper Belt. This is the asteroid belt that we talked about earlier. All right. This is how far light can travel in one day, in 24 hours. And keep on going, keep on going, keep on going. Oh, notice here now we've got a nebula. A nebula is the birthplace of stars. They think it's after a star explodes and blows out all of its gases and chunks of different elements, that's the part, so it's both the death of a star, but then the leftover bits they think are where new stars are born. And again, you can just keep going and going and going and going. It's ridiculous how far away things get. All right, so take a look at that for yourself. So now go ahead and get your homework done. Remember that you need to come back and watch these videos underneath the YouTube links and take a look at just these few here. Remember, you can skip the sun till another lesson, and then make sure you get all of the homework done out of the textbook for topic number 1 and read through those pages that had the planet information. And that's it for this first topic lesson.